Okay, so we're given this diagram here and we're asked in part A to work out the vector AB. Okay, so it's in bold, so that means it's a vector. When we write our answer, of course we can't write in bold, so we will put an arrow above to show it's a vector, and if you can see then, think about the direction here, we're heading from A to B. So we want that vector there. So remember, a vector has got a direction, so we're heading in that direction, and a size, okay? So, you know, we're starting at A, but we want to stop somewhere, and we're stopping at B, okay? And that's what we're asked to get. Now, we don't know anything about that direction there, and that size, but we do know these vectors here, taking us from the origin to A, and the origin to B. So what we can do, we can form a path to get from A to B, okay? We don't have to go sort of think about going directly, because ultimately a vector, okay, as long as we start at the right place and end at the right place, then it doesn't matter how we sort of get there, okay? We can use other sort of vectors given to us and it will equate to the same as what we have here, going from A to B. So you notice instantly we know what it is to get from A to O, okay? Now they actually tell us in the question, OA, okay, going from O to A is little a here, okay? And you notice again it's bold. So when you've got a single letter, remember, we won't put an arrow on it because you know it's just a single letter. It's not as if it's going from one to the other. So it's called little a. So we'll underline it then as a vector, and that's going from O to A. But if I'm starting at A, I want to go to then O, don't I? I want to sort of like go in the reverse direction. So instead of O to A, which is that there, I'm actually going the opposite way, A to O. So quite simply, A to O will just be the reverse of that. So we're just going to be negative A, okay? Just sort of undoing it. So that's important there to note. So yeah, back to this then. So A to B, you're going to go A to O, okay? And then once you're at O then, you just need to go to B. So we're going to add then the vector, OB. So we've established then A to O is negative A. Okay, it's the reverse of that, and then O to B is little b. So we get our answer then for AB, the vector AB, and that would be then, we can write it the other way around, B take away A, okay? And we're done. So with part B then, they're asking for the vector AC. Now, you'll notice AC, okay, or you'll notice C is a long way along this path AB, okay? It's not quite as long as B from A. Okay, and they're given us in this ratio, it says the ratio of BC to CA is 1 to 2. So diagrammatically it's quite good here because you can see that this is like one part here and we can sort of split this up then. So we've got another 2 parts here, haven't we? Okay, so in total, when you see the ratio 1 to 2, there's like one part going from B to C, satisfying that there, and then C to A, there's 2 parts, okay? So we want A to C. Now, I think we just need to appreciate that A to C, okay, if you think about it, is sort of like, it's going along the same roadway, isn't it? It's going along the same pathway as A to B, but it's not quite as much, okay? But you need to appreciate it's going in the same direction, okay? It's literally on top of AB, yeah? It's just going in the same direction. So it's going to have the same sort of vector characteristics as this, but it's not quite as far. So it's a fraction. So if you think about AC as a fraction of AB, okay? Now, it's quite simple to see the fraction as well. So AC is like 2 parts, yeah, of the journey out of 3 in total. So we can literally say that AC is 2 parts, 2/3 of AB, okay? So it's not quite the full journey, it's 2 out of the 3 parts there. So we can literally say then AC is 2/3 and AB we've already worked out to be B minus A. Okay, so you can sort of leave it like that, or you can expand the brackets. It's perfectly fine to leave it like that. With C then, we need to work out BC. Okay, now this is an interesting one, BC, because BC is sort of going in the opposite direction of that we've just been going in, because we were going from A to B, yeah, or A to C. Now B to C means we're going this way. Okay, and again, we could, if you want to, we could work out what CB is to start with. We could work that out first and then appreciate it's the reverse of it, okay? And it's easy to see what CB is, okay, because CB, if we think about it, is like, it's on the same pathway as A to B, yeah? So it's in that direction, it's going to have these, it's going to have that sort of characteristic there, but it's not going to be the whole of A to B, it's only going to be one part out of 3, okay? So it'll be a third, so we can say that's a third of AB, okay? So CB will be 1/3 of AB, which is B minus A. Now in this case, I think I will expand the bracket. So I've got 1/3 B minus 1/3 A. I'll expand the bracket because it's slightly easier then to see what we actually want. So in C, we actually wanted BC. So we wanted the reverse of this. Okay, we actually wanted that direction. So of course we reverse this. So it'll be the minus of this. So it'll be the minus of 1/3 B minus 1/3 A. And that works out to be 1/3 A minus 1/3 B. So we just switch the signs. Okay, and finally then we want a vector. It says OC. Now OC, if you think about it, to get from O to C, well, we just need to go OB plus BC. Okay, so I'll write it up here. So OC will be starting at O, going to B, plus then BC, and we just worked out BC. So OB is little b, and BC we worked out a moment ago to get 1/3 A minus 1/3 B. So that works out to be 2/3 B plus 1/3 A. Okay?